standard. Good morning, class 4. Please sit down. So, today's plan. Remember what we were doing last week, Ohm's Law. Okay? And today's task is we are going to investigate Ohm's Law. We have built up some stations. Okay? I'm going to explain you how it all is going to work. First, we should know the objective. The objective for today's lesson is that we are going to investigate Ohm's Law. Okay? Ohm's Law, we remember, that is I directly proportional to U. Okay? That means the current flowing in a circuit is directly proportional to the voltage present. So, what we do is, first, before we start the lesson, you have to do a lesson review. That means you have some links uploaded on your laptops. You have to try these links. These are the links for animation films, where you see the circuits and the flow of current and the voltage changing, and how the voltage affects the resistance, okay, or how the resistance affect the value of I, that means the current. So, first you do a lesson review, you try all these animations. After that we have lesson activity. Lesson activity is group wise you will come here and try this experiment. Then there is an extra activity, that is extension to the lesson here, and extension is that these values what you have noted down when you are doing the experiment, this data you have to enter in the Excel sheet and plot a diagram. Okay? You have to plot a graph of voltage against current. Okay? This you have to do. Once you have done that, you have to upload this your task on LMS. Okay? Then I am going to do the grading. Okay? You get the grading for that. Then we have an expert online here today. So, if you have any question on electricity, you can just ask him. Okay? Group wise means one group at a time. You can go and ask questions to the expert. And after this, we are going to test the knowledge. That means we do a quick revision in form of a quiz, okay? And that interactive quiz. The questions will be flashed on the whiteboard. You will get these remotes, okay, on these orange devices. You have to enter your answer here. That means the answer is multiple choice. You have to enter your choice in this, okay? And then we are going to evaluate the quiz. That means we are going to see how many right and wrong answers we have in the end. What is Ohm's Law? Do you remember? We did Ohm's Law. Yes? No?
In 1826, George Ohm discovered that the current is proportional to the voltage.
That's true. Okay, so the Ohm's Law says that I is directly proportional to U. When the value of I increases, U also increase. And this we are going to investigate today. Okay? So, there is an experiment where you are going to increase the voltage and note the current for that. And then you have these two values, you have the voltage and the current, you have to find out the resistance. Remember the formula for resistance, how to calculate resistance when you have voltage and current given?
U times I?
No, we have to find out resistance. Okay, resistance is, yeah, anybody, Emmy?
R is U divided by.
Yeah, that's right. R is U divided by I. That's resistance. Okay, so this you have to do. And before doing all this, first please try all these animations which are uploaded. We have to work in groups. So, we can just do the grouping. Let's do it that as you are sitting, we built up the group. So, this is group 1, 2, 3, 4, and you 3 can be in one group. Okay? So, each group is going to try first all the animations, turn wise. You will come here and try the experiment. When you have done the experiment, you have to enter the data in an Excel sheet. Excel sheet is already prepared for you. It's on your laptops. You have to enter the values of U and I, calculate the resistance dividing U by I, and then draw a graph. You have to plot the voltage against current. Is that clear to everyone? Any question? No? Okay, so let's start.
Experiment können wir aber nicht machen. Ich bin das nicht. Ich es nicht. Recap. Der macht nichts. Schau das mal an. Recap und wir wissen.
Da muss man da hoch es kopieren und natürlich einen Link ein.
Wieso nicht gleich aus? Der macht nichts. Schau das mal an. Probierst du, vielleicht kannst du. Du bist der Profi. Siehst du, der macht nichts.
Okay, dann gehen wir
Nein, wir gucken.
That looks good. Oh, yeah, it's good. It's great. Hey, that's really good.
Drüber.
Okay, so what else is
Geil. Welches ist das?
try the just try them. Let's try. This is I, isn't it? So it's current.
Das geht doch.
Just make less resistance and maybe we'll get more current. Okay, that's yeah. You have to talk. Okay, just show. Yeah, it shows the much more current. So this shows circuit. I think so. It shows the circuit. And there, here is the voltage. Here comes the voltage. I have no idea what this should mean. Okay, now we have to talk. But that shows the electron. That shows the electron. It shows how much electricity is pushed in. How many? And this is how quickly. Yeah, and okay. I'm not quite sure. Oh, maybe so that means I times R. Because there's IR. So let's just make I times it R. This is the formula.
Yes, man. You
Okay, if we just keep the resistance and turn voltage down and up, they both get smaller. Yeah. It also shows Ohm's law. Do you see when you increase L, R also increases? And now decrease L. And when you now increase A, R also decreases. So it's stop it. It's indirect proportional. Do you understand? So when A increases, R decreases. So yeah, I think that's the formula. Whoa. Wow, that's big. And when you L increase, decrease L, please. So R also decreases. And when you decrease P, oh yeah, look at this. Wow, that's the formula. Oh, A, wait. Yeah. Can you open the other one? Wait, I have only 12 this. So wow, there's so much interesting. Oh no, the third one. With this. Oh yeah. So voltage is directly proportional to I. So when you do you see it? When you decrease resistance, I gets bigger. So, that's the current. Like the arrow showed the current. So, and here current. Oh, it's messy.
And when you increase the resistance, the current gets less.
Yeah. And why are you taking my laptop? So, it's here massed in milliampere. So how less it is, more particles are. What? I can't understand. We're done now. So decrease it. No, not so much. So the resistance is directly proportional to voltage, right? Or not? Or decrease it? No. It's indirect proportional to I. So when it gets bigger, the arrow, so the current gets also bigger.
Yeah.
And here it is mass in milliampere. So the current, now it is 15.9 milliampere on voltage. Oh, and now try to get R and I equal. What happened? No, it's a bit. Now decrease voltage. So I gets bigger. It's so fascinating. And the arrows also get bigger, so the current is also bigger. Okay, let's try the last one.
And more wire.
Yeah. Let's try the last one.
Not really.
We should call her, right?
Miss Mishra? Excuse me, Miss Mishra?
We have some questions.
Yeah. Here we can see resistance,
Yeah.
and turning this up and down, it's directly proportional. But what exactly does this symbol stand for?
We have done in the class. Do you
Yeah,
remember?
is it specific?
This
then?
is
It's
rho.
specific, yeah.
But that's exactly specific resistance, because here we are not using rho for density. We are using rho in this case for specific resistance.
Okay.
And now what you do with this animation is you try to just push the
So these dots, they mean resistance.
R is for resistance.
okay.
Now try. Okay, first we make it minimum. Change. Now when the specific resistance is minimum, then the value of R is so small. That means there are less particles there, and
the current
easily
can
flow. Electrons can flow. Now when this is maximum, what happens? See.
Yeah.
Then you have bigger value of R. Yeah. Okay, that means this is directly proportional.
So the
Bigger the
electrons don't have space to
they are being blocked. Yeah. Okay. Now what? Same you do with L. L is for what is L for? For length. Length of the wire. Okay. And how it changes? Is it directly proportional?
Directly, because it gets bigger.
Yeah, exactly. When L increases, R also increases. That means the longer the wire, the higher is the resistance.
And the last is area.
Area. That's
But
area.
these are inverse.
Pardon? Once again?
Area of cross section.
Yeah, area of cross section.
And these are inversely proportional.
This is inversely proportional. So, what is the conclusion now? Conclusion is the thicker wire has less resistance or more resistance. What do you say?
A thicker has less.
Thicker wire has less resistance because there is more area there. Yeah, area of cross section.
Where the electrons can pass through.
Exactly. Yeah.
Okay, thanks.
Okay, now try the other animation.
Okay, good. Thank you. So we just go there and try the others.
Okay, no, we are going to do the experiment first. So this is the first experiment set for Ohm's law. Okay, check the circuit, check if the ammeter is in series and the voltmeter in parallel. Okay, and we are using this Code 6. Remember, Code 6 is a software which helps us to do the lab calculations here. In the physics, instead of using the manual, these red boxes, today we are using this digital voltmeter and ammeter here. Okay? So what you have to do is, here is an adapter. This is a knob to increase the voltage and to increase it coarsely, means like at bigger values. Okay? So you try with this knob, increase the voltage. Let's start from 1 volt. Okay? For 1 volt, you have to check the value of current flowing through this fixed resistor. And what is the value of fixed resistor here?
It's
10 ohm. We are taking 10 ohm. Okay? And note down the current passing here. Then increase the voltage. Make it 2 ohm, 3 ohm, and so on. So then you need the different values of A. Once you have these values, you have to use the Excel sheet and fill it in, draw the graph, and upload your work. No, Excel no, it's not here. We are using this laptop only for meters. Okay, so you have to use your own laptop for that.
Okay, so you should take it down to 1 volt or
Yeah, I tried to.
No.
It's very difficult.
It's too much.
yeah.
Perfectly.
So it's changing.
So it's I think
Changing.
Yeah, it's changing all the time.
the most time it's put from 9 to 13, right?
Now it was
5 to
5 to
13.
17. 17.
10 to 20, we could say.
Wait,
5 to 17.
5 to 17.
but that's a wide range. I mean, yeah, it's a wide range.
Okay.
It's a bit much. We just
So now try it with 2 volts.
let's say. Yeah. What would you say? I don't know, but Ines was right with saying it always changes between 5. Sometimes 20 comes together.
Yeah, but it's not so.
Let's just say
5 to 17.
or 9 to 17.
Yeah, 9, yeah.
Okay, 9 to 17.
9 to 17.
But
Okay.
right now it was just
So
Now I'm going to turn it up to 2.
What don't we have to write it down?
I can
Remember it.
You can
remember it.
remember.
Yeah.
So it's now 2.
Well, I think that
Yeah, I agree.
it doesn't matter.
So it's
0.13.
It's the same. It's 9 to
No,
13.
no, it's more. It's 13.
It's more equal.
And it doesn't change that much.
It doesn't change, yeah.
9 or 13, sometimes 3. 17.
Yeah, no, it doesn't change that much. So, no, yeah, no.
Okay, yeah. Well.
Yeah, 13. I think it's
But
13.
but it could
Wait, don't
be
drop the table,
possible
don't drop the
when
table.
1 voltmeter is like 9 to 17. How
It
could
was
2
20,
be
9 to
13?
20.
Yeah, I also
Yeah,
don't know.
9 to 20.
17.
Or isn't it directly proportional?
Yeah, it's directly. It's
Yeah,
not
well,
so
that-
more voltage,
So it
but
has
more
to be
current.
more,
Yeah.
but
Of
it's
course,
less.
It's not less.
It's not.
No,
less.
it's not.
So we
less.
have to do by 1 voltmeter. It's let's say 5 to 9. So
5 to
and
9.
by 2
I would
it's
say-
13.
Yeah,
Or?
0.013.
Yeah, I would say a bit 5 to 10 about it. So it's
Yes,
About
yes,
5 to 10.
Could
and
somebody of you start Excel?
0.0.
Start Excel.
Yes.
Yeah.
Start, yes. You can sit there, I think.
Yeah.
I think you
Stand
understand
the
it
best
best.
of us.
Yes.
We're not
Okay.
so good in computers. So it's okay, so
Okay, should we turn it on to?
Yeah.
Can we help just?
So you're gonna problem, yeah?
Yeah.
Okay.
I think
Let's have a look in it.
it's false formatted because it always changes decimal numbers.
So you need a floating value with
Yes.
how many
I
positions?
think 5 would
5
be enough.
positions. So
yes.
in this case, you just click right,
Yes.
open the item formatting cells, and at this place you can turn up. So you set 6 to 7,
Yes.
maybe? Okay, we take for the first time.
Yeah. I think it's enough.
7
Decimal set.
and just to do it in all these fields, you pull down
Yeah, and these two.
and pull to the right direction. So we go back and you try to format it again. Okay?
So I go right click,
Yeah.
then on
Open
formatting,
formatting of cells. Click on
then
it.
decimal
And,
sets,
okay,
and okay.
that's correct. Now you do the next fields. You can just pull, or you just do it again.
And can I get
So
these?
that's not okay because you have the same values then in all these fields. You just
okay.
need it for the different fields. You can format them all at once and try again just to open it for. Do it again. Just mark all of these fields, all of these cells, please. Okay. No, not with this. May I help you?
Yes, please.
So you just do a regular marking, you know? This mouse is signed white. Then click right. Open formatting
Okay, yes,
cells.
yes.
And at the end you go at standard or at figure. And now you can increase until you think that's correct. And now you have the different values in there and it's for all those fields, okay?
Thank you.
So you can go back and put in the correct fields again.
Okay.
Next values, please. We have about
Small
We have a
problem.
problem, because the values don't really change.
Yeah.
They nearly always stay the same, but
we
once
changed the
we
volt,
took 8 volts,
and then we took 4, and
it
it's the same.
okay,
so-
same values again.
Can you help us? I don't think that
and it's
is
really
works.
strange.
Miss Mishra?
They change a bit, but not
Yeah.
really.
They're always like
Open
3,
the,
15,
physics part on
17.
it. So the values don't really change.
No, it's like there we can change it, but when it comes to ampere, it's always 9,
same?
13, 15
Yeah,
or
but-
17.
Yeah, it
Or
should never 20.
So
We have checked it, but
It's strange. They don't change
They don't
so
really
much,
change.
just a bit, and it
just
Sometimes they
logical.
don't
Can
even
we turn
change.
it off for some time?
Yes.
Maybe that will work. Where
Turn off
This?
yeah, that. Yeah, wait.
Okay.
Let's see.
I don't get why it's
yeah,
we
we
don't
not
always
change.
understand.
It should change.
because by 3
Because
it was
they're-
also 13
Yeah,
to
because
17,
they're
and by
directly
7 it was
proportional.
also
So
13
if this
to
one gets more, then this one should get more as well.
yeah, and it just stays the same.
But yeah. But it has worked, right?
Yeah, it was working. Now the problem is with the resistance, with time it gets hot, the wire. Okay?
So maybe
You don't get the right value, so we have to wait for
The
some.
resistance is more than
Yeah, but actually we have taken a fixed resistance, but wait, we have to see. Is it off now?
it's always 9,
Should we
13.
turn it on?
I can still see the green light. Turn it off. There's a switch behind. Can we turn it off for some time? Yeah.
I have a question. When you do it like 10 volt, would it be an exact number or would it change? Or is this normal? That's change?
It fluctuates. That's true. That's true. It fluctuates because we're not doing that accurate experiment here. So it is fluctuating, and this is sensitive because it is digital. If we have analog, we don't see that difference. But here we can see the minute difference. So we see that the values are fluctuating.
Should I turn it on?
Wait.
Just wait a few more minutes.
Yes.
We wait for some time. Wait.
38 ist Hallo.
Ja, das soll so raus.
Wie ladet man das jetzt hoch? Magst du es wirklich machen, Tim?
Ja, ich bin der Expert hier. Hello, I'm Ines.
I'm Timna. I'm Anja.
I'm Emmy.
I'm Wendelin.
And I'm Simon.
And we have some questions for you because we're very interested in electricity. So it would be nice if you could answer it.
Okay, so the first question we prepared is, why can a bird sit on a power line?
Okay, this is possible because a bird only touches one line. If the bird were to touch another line, the current flows through the bird. And the current flows also if it touches also the ground.
Okay.
Okay. So,
And do you think electricity will be wireless one day, just as computer software is wireless today?
Yes, the technology already exists, but only over short distances. You need a lot of power to transfer electricity or energy over a long distance. Maybe in the future we could do this.
I wanted to ask why many cows die during a thunderstorm, even though the lightning doesn't hit them directly.
Yes, the current flows along the path with the lowest resistance, and ground has a higher resistance than a cow, and so the current flows through it.
Okay. So, has anybody other question? I think maybe
Here, how does lightning start and how does it end? So in a thunderstorm.
Okay, yes, you have the cloud and the ground with different potentials. And the cloud has a high potential than the surface of the ground. When the electric field is strong enough, the charges could flow through the air, which is more or less an insulator. But then it takes the shortest course in the air that has a very low electric potential energy. And lightning hits the ground and the current flows and the potential is reduced and then lightning stops.
Okay, thanks.
Okay, so
Thank you very much.
Okay.
Thank you for answering the questions.
yeah.
Thanks.
Bye.
Bye.
Bye-bye.
So there are a couple of minutes left. I hope you have all done the experiment, the research, everything. So now be ready. We are going to test your knowledge for today. So you have to participate. We start with the quiz. Okay? Professor is going to explain you.
So in this area, we want to check up if you do your quiz in the correct way. And for this, you have these expressions. If you're getting a question, you just press the button that's open, and after having pressed, you get a question, and you get a feedback that's called cool or whatever. You delete that and start up with the next questions. After you have finished your last questions, you can check up your different answers, and if you have done it correct, then it's okay, and you can load up your quiz for the next time. So after having done these expressions, you put in the information at your quiz sheet and load it up at the .learn LMS platform so that we can work out until the next time how your work really was. Okay?
So have you over to which one of these factors in a metal does not affect the resistance of a conductor?
A, the material, B, the length, C, the thickness, and D, the density.
It's density. Yeah.
Oh, it's cool. We got it
Oh,
right.
we got it right!
Yeah.
Okay.
Okay, so
I like the resistance decreases with an increase. So I think that's true.
Okay, so this
We're finished.
It's
We're
finished.
finished.
Yeah, we're
finished.
I got it cool.
Yeah, we too.
Description is what it's like. It's the how we. I don't know.
Should I upload it? The data?
Yes. On LMS.
Yeah.
Does it work?
I don't know.
But have you copied it in? It works.
I just tried one.
It's progress.
No, it's mistake.
So
Okay,
go back.
let's go back.
Oh, that's it.
I have it.
Yes.
Yeah.
How have you done it?
Yeah, you
Can you
just
help
like
us?
you, but I don't know what's wrong with yours.
Nothing is wrong with us.
Go. It was there.
Wait.
Ines.